cheap solar power, batteries, and electric vehicles are changing the transport and energy sector as we know. I bring in guests to this podcast who will help you with their ideas to navigate this energy transition. By the way, this episode is also available as a video on our YouTube channel. Just search Energypreneurs. Thank you for joining.
Hi, Emily. Good morning from Manila.
Nice to see you. Greetings from Atlanta.
Yes, we are just on the other side of the world, 12 hours time difference, no?
Yes, but still so close.
Yes, yes. Now, we had a couple of discussion with you over the years, and you was one of my first 10 or some episodes guest, and now we have done almost close to 250. So thank you for coming back.
Well, thank you for revisiting the conversation with me. It's always fun.
And you must be doing a lot of interesting stuff as always. Maybe you tell us what's happening.
Yeah, this journey continues to get more interesting, and it continues to show us just how important water and water infrastructure is to the energy transition. As if you haven't heard any of the episodes previously, Emrgy is a renewable energy developer. We focus in water infrastructure. That is typically a very old, aging asset, but a very critical asset to municipalities and to rural towns all over the world to carry water from rivers out to farms and to cities. And we take that water infrastructure, we invest in it, we add renewable energy, namely hydropower, but sometimes floating solar as well as energy storage. And we generate new life, new revenue from that water infrastructure. Many of our projects today also include an element of water stewardship. This infrastructure is so old that it's often very inefficient. From the time water is diverted out of a river and taken out many miles or even hundreds of miles out to farmland, often water seeps through cracks in the infrastructure or it evaporates. And so we also have an opportunity when we come in and deliver renewable energy to also do irrigation modernization, to upgrade the infrastructure. And then we actually, part of our revenue model now includes monetizing that stewardship effort, and especially around water conservation and the value of that. So it's been a lot of really interesting projects, a lot of really interesting communities that we've been working with and serving. And then also new iterations of power as well, power delivery. Actually, today, in New Mexico, our team is installing a completely grid separate microgrid that uses our hydroelectric power as a base load for the microgrid. It combines in floating solar and energy storage to essentially allow for a very remote area in New Mexico to have intelligent water operations using automated gates and different systems that really bring it up to some state-of-the-art irrigation technology while not having really any access to the grid whatsoever. And we're doing fun projects like that. We're exploring new opportunities in really bringing that water element first and foremost right alongside the energy and growing our footprint around, especially the United States, but of course the world as well.
Yeah. Maybe I think if you could also explain that you are technology-wise in hydropower, what is rooftop solar to solar power in general. You are the micro side of the hydropower, because hydropower scares people off. You have to build a dam, block everything, resettle so many people, and takes 6-7 years to build. But you are completely opposite of that technology, right? Although hydropower.
Absolutely. Yes, that's really what Emrgy is fully formed around, is the realization that water can be the most valuable renewable resource that we have. It's controllable, it's predictable, it's dispatchable. Yet hydropower always comes with these connotations that it has to be a massive multi-$100 million project that takes decades to design and permit and construct. And we need power now. Everywhere in the world needs power now. We don't have 20 years to wait. And at Emrgy, we're bringing that the form factor of solar and wind into hydropower. So we build standardized modules that we place the number of units along a canal to harvest that energy as it flows downhill, as opposed to impounding all that energy and taking all the head pressure in one machine, because that's so environmentally invasive. And that's really what drives a lot of the permitting and cost aspects. When we can distribute that energy along the channel and harvest it, bring it all into one collection point, it can still be really exciting amounts of power. Our individual modules are small. They're between 10 to 25 kilowatts. But when aggregated together, and if you add floating solar in the middle, in between the turbines, you can end up with very power dense projects that have really compelling generation profiles, because you get the 24-hour generation from the hydro, and then you also get the peaking solar as well. So we call ourselves a bit of the solar panel of hydro, and we have a fleet of equipment that's already installed at 4 locations around the US, 5 including today, and also in New Zealand as well.
Yeah, 10 kilowatt to 50 kilowatt is very easily relatable to hydro. Any large residential installation is about 10 kilowatt. People say, okay, I understand. But when you say about hydro, 10 megawatt is considered very small in your typical hydro. So you are a very different hydro. And last time you mentioned some of these projects can be installed in a day, which is unthinkable, unheard of in hydrotech, no?
Absolutely. Yeah, we got it right today because we went ahead and set up cameras and GoPros like at the beginning of the day, because I've had a number of experiences where we have the contractors that on site. I plan to videotape or capture the installation going in, and the contractor will have a question over at the side, and we'll talk for 45 minutes. I'll come back and I'll miss half of it. And it can be installed very rapidly. In fact, some of our key EPC partners, they have really refined some of our messaging away from construction and development projects over to it's the installation of an engineered product, because the product comes engineered, it comes assembled. We're simply placing it into the channel and then hooking it up to the next one and the next one and the next one. And they make the analogy of power poles. You put it in, cable it to the next one, because it's truly that simple, that plug and play. And we actually don't connect into the existing infrastructure in any way. The turbines just sit on the channel and are self-ballasted with their own design.
And the word that you use, plug and play, again, that's completely another change of mindset, right? Hydropower, plug and play. How big is the box, right? There needs to be some construction made locally, and also you must start it. You mentioned that you also started do some 3D printing of some of those things. Can you maybe expand on of those? Because some of my listeners are overseas, all over the world. Someone might say, I want to do that technology, but how much of that do I have to import? How much of that can I print or make locally?
Yeah, absolutely. And our goal is to make things as simple as possible to be adopted all around the world. The system itself is a vertical axis Darius style turbine, one that's existed in form factor for many centuries, really. And we manufacture those drive lines in the US, although to your point about 3D printing, we have 3D printed the full drive line. We've also 3D printed tooling to be able to recreate at mass scale those drive lines in a very low cost way. In addition, that vertical axis drive line sits inside of a precast concrete, what we call our flume, but it's really just a ballast that holds that turbine in place. And those are typically casted locally, and we can either ship a steel form to be able to cast those locally, or we can 3D print or send the files to 3D print those forms locally. And the actual assembly work is very simple. It's high-tech, high-paying jobs. However, it doesn't require any harsh chemicals. It's not a black box. It's not something that needs a specialized skill set or degree to do. And so it can be assembled and installed by labor teams all over the world. I'll tell you a story. When we first met the water district in New Zealand, where now they're hosting one of our projects, it was the middle of COVID. And during COVID, New Zealand's borders, as many, were closed to outside residents, outside citizens. including Americans, where our company is based. And they had a really serious problem that needed to be solved. Their canal was many decades old, as I mentioned earlier, as many canals are. And they were having really problematic efficiency problems. From the time they diverted the water out of the river to the time that the channel had discharged back into the river at the end, they lost 30% of the flow due to inefficiencies and seepage into the ground. And so they wanted to be better stewards of that water. And they came in and they added a synthetic lining to the channel that's impervious and kept all the water in the channel. What they didn't anticipate was that it not only now had more water flowing through the channel, but the water was flowing at a faster rate of speed because the friction in the canal had been reduced from an earthen, rocky, crack-filled canal to something nice and smooth and channelized. And they were having a lot of trouble delivering water to the farmers. They couldn't make the turnouts they needed to make. They didn't have enough head pressure. So they called us and they said, look, we either need to dissipate energy in the canal. We need to throw rocks in the canal. We need to build up impoundments or structures, or we need to harvest energy out of the canal. And we'd like to do that instead. Because we weren't allowed in the country, we essentially kitted up the turbines just like an IKEA package, if you will. We shipped everything to them, including the form, and then on site, having never seen our system, having never taken a training course, having never done any real preparations or skills development in this area, they were able to assemble everything within the course of just less than a day per turbine, I believe. And they casted the concrete, they placed everything together, they installed it in the channel and connected it to the grid, all without one of our employees ever stepping foot in the country. And that was a huge accomplishment for us because that is the kind of simplicity that we want to drive. Obviously, we want to be a part of all of these projects. We want to travel anywhere on the planet that delivers these, but when that's not possible, people still need power. And so we want to be able to enable that all across the world. And I think we're on a really good path to doing so.
Amazing. Just you triggered a memory. We were in a remote part of Kyrgyzstan, which is very big on hydropower. They control two of the largest rivers in Central Asia. So I had a large hydropower there, 1,300 megawatt. So at the sideline of that, we are doing solar. So we went to a remote area, lot of water stream running all around, but they don't have electricity. They had electricity in the former Soviet days because now it's not commercially viable. And I think the nearest distribution substation, I don't know, 10, 20 kilometers down the hill, so no one connect them. So they use diesel, genset, candle, very basic. So we put a solar panel up and the whole family was saying, mother was telling to the kids saying, this is light. And she did not know what light was. When the LED comes on, because like you, it took us half an hour to install a solar panel and a battery and connect up everything. And this little girl was touching light and said, oh, light. So it's, as it was getting dark, we had to leave. And I was just thinking how they will pass that night seeing suddenly light, which they never saw. They just have a couple of torchlights. And in those situations, I was thinking, oh my God, they have to bring solar because there are so many trees. The winds are so big, but your solution could be ideal for them. Micro hydro, just you plonk it in and 10 kilowatt will be plenty. I don't know, they will know what to do with it, but once you have electricity, you can run motors, you can do drill,
Exactly.
run a small factory.
Then the demand will grow.
Then you can
Yes,
put one for each neighborhood. This is really off-grid electrification because sun doesn't go inside the jungle because trees are so big. So if you really don't want to touch nature, still want electricity. And last time you mentioned, I really love that term, saying this is a nature's battery. You have all in one. So what's
It
your
is
expansion
nature's
plan?
battery.
There's so many jungles around the world. What's your expansion plan, Emily?
I hope you can help me with that one day because we have been very laser focused on mastering the solution that we're delivering. We know that we won't be able to stub our toe and learn it the hard way when we're very remote, and we want to make sure that as we're starting to expand, that the technology has been very closely validated, has a lot of experience, and that we know how to do that in a sustainable way. One of the things we did recently invest in since the last time we spoke on this podcast was a study completed by an independent engineering firm, Leidos, to review the technology, review the reliability over operating hours, review its uptime and availability, so that as we start to think expansively and outside New Zealand and the United States, that communities can trust that what we're delivering them is something that's going to be robust for not just a few years, but decades. That is another promise of hydro. The average age of a hydroelectric facility around the world, I believe, is now over 80 years old, because there's so much capacity that has been installed since the 40s or the 50s. And for us to deliver hydro, it looks and feels like solar, but we feel strongly it needs to hold the value of hydro. It needs to be high capacity factor and uptime. It needs to be high efficiency. It needs to last for hopefully 80 years old with the proper care, proper maintenance plan around it. So understanding those maintenance plans, understanding and validating the technology. It's not that we've been just looking at this as a US opportunity. Definitely, I would say that the global market for distributed hydro, just like you talked about, I've personally looked at several dozen, and I know there's hundreds of, if not thousands of miles of canals across Kyrgyzstan. There is so much opportunity. We just have to find the right partners and make sure that we're building sustainably in those areas. So we're very keen. We are exploring opportunities today in Asia as well as in Latin America. We just exported our first equipment over to Europe. And so hopefully that will be our first flagship installation in Europe soon. And now it's time to grow. And we're excited to do, but want to make sure we have the right partners in place first.
Absolutely, because poor people pay the most for electricity on a sort of cent per kilowatt hour basis, we all know, because they use the most inefficient technology for generation and also for consumption, right? So in remote rural areas of Kyrgyzstan, or you pick up any countries, even in Indonesia, Malaysia, far-flung areas in the jungle, they must be using one of the oldest diesel genset that barely work. You need it's like an old internal combustion engine car versus electric car argument, because you will have a simple technology, doesn't generate that much heat, whereas you run diesel, it generates heat, wastage and others. You need to carry whole sorts of oil inventory that comes very far away. Things get stolen, theft, leakage, and then of course environmental mess up. So in terms of climate mitigation world, I think there's a huge opportunity if this technology taken to the sort of global poor, lack of a better word, in the far-flung areas. Even in remote Australian Aboriginal community, Australia has less water, but when people are dispersed, like in Western Australia, Horizon Power started taking the grid down, because if you have few families and there's nobody in between for a long time, it's better to do a microgrid. Now, if you have water, if you have microgrid, yes, solar is an option, but of course, hydro can be, because you have a built-in battery. Once you have water stream that runs 24/7, no?
Yes. And truly, the combination of all of these is better than any one on their own, really. When you look at the economics around a solar battery microgrid, you're oversizing quite a bit of the solar to make sure you're charging batteries to be able to use over that cycle. When you add baseload or close to baseload hydro in the middle, what happens is you end up needing a lot less solar and you need a lot less storage. But the three together give you that full package that you need to be able to match a lot of the energy loads that you have. And so we have been looking at not which solution, but what combination of them is really the best. In fact, a lot of these projects we're doing right now are really setting up a foundation for us to scale this grid separate microgrid that we're doing in New Zealand right now. There's another one we'll be doing in about 4 weeks that is also a microgrid. This one will be in Idaho, where there are many thinner pivot irrigation systems being used up in Idaho, but many of them are diesel powered, but for the same reason, carrying a distribution line out for miles just to power a 50 horsepower center pivot doesn't make any sense. Yeah, there's also sometimes farmer housing or other electric sheds with electrification needs and other things around as well. They have a canal that runs right along their field. We are going to be placing in hydro as well as solar and batteries, but also keeping that connection to the diesel. So their diesel expenditure is going to go down about 95%, really just have it there for backup because they cannot afford 1 minute of downtime throughout the year. If they're not watering their plants the way that they need to, they risk crop loss or having lower value crops. And being able to have a kit, if you will, to be able to replicate and ship over for a place like you described, that's a remote community. They have access to water, but it's intermittent or it's seasonal or different things like that. Being able to take and bring together the baseload hydro with the solar, with the storage and diesel backup can be potentially the most robust, reliable solution of them all. And we'll be doing that in July. And so excited to back on that as well.
Yeah, but communities that I'm thinking of may be very different from the communities that right now you are designing your project for, because some of those people who are used to a lot of intermittent power, a lot of interruptions, load shedding, even if they get maybe 18 hours a day, that's quite an improvement from what they are getting. In those cases, even a one technology is more than enough because they might be very cost sensitive. Just look what's been happening in Pakistan. I've been reading that they installed 2.6 gigawatt of solar because electricity tariff was so high and solar power has become so cheap and power is unreliable. So people just started buying solar and installing on rooftops. So one of our Pakistani colleagues was explaining I was the largest importer of solar panels last year. So it's amazing from nowhere, right? So I think that that market will be also very interesting for you, where people might just say, all we care that reliable, simple technology that will last for a very long time so that our sort of ultimate cent per kilowatt or cost becomes very low and run by a community. Because 10 kilowatt in the right place can serve very well a community, especially if it is flowing continuously and others. And one can always have small batteries here and there. I think you are sitting on a really big opportunity.
Really big opportunity. And just to your last point, when you really start to think of it in energy instead of power and how far that can go is when the numbers get really inspiring, truly. I think living in a predominantly solar renewables age, the conversation tends to always be about peak power. 2.7 gigawatts, how much can we generate? And when you look at a 10 kilowatt residential load, as you mentioned, that's one large resident. But when you think about solar capacity factors in the 18 to 22%, if you have a channel, a canal, or water flow that's running 80% of the time, that's really like a 40 kilowatt solar load because you've got 4 times the amount of available hours over the course of the year than you have in solar. Now, of course, you have to think about your living patterns and when you're using energy and all that, because if you're generating power in the middle of the night and you're a tribal community, not used to using power in the middle of the night, finding other ways, whether it's through food production or refrigeration or things that are 24-hour loads and matching that to it can be hugely valuable. But when you think about a near continuous flow on that 10 kilowatts, it really can be meaningful power to a remote community that has already very low load profile, and just having that much larger capacity factor.
Yes, absolutely. What pops into my mind other than hydroponics that we discussed last time, that you can turn those extra kilowatt hour into kilogram of whatever fruits or veggies you want to make. But then again, the way the electric vehicle revolution is going on, especially three-wheelers and even electric boat, I see slowly happening. And one project that we are working with a company in Bangladesh, it's about a battery swapping stations. So these little batteries that you can take out, like you take out from your old post office locker box, pull out a thing and just put it on a car and the car runs away. It gets done within a minute. So if your micro hydropower is fueling few of those charging, people will not notice. They're just end of the today, put all your batteries up and system AI can automatically optimize how much to supply people, and whatever is left over optimize and charges, so that by morning all batteries are charged. They pick up the batteries, take it to school, take it to the boat, take it to whatever they are doing, and then your nighttime continuous power can slowly recharge all. That will work really well.
Listen, ever since we talked a bit about this in our last call, and I have had sleepless nights over the inspiration on this, because I've long said, look, these last 20 years have been a lot of figuring out both, not just the technology, because obviously solar and wind have been along, and hydro is as old as it gets, but really modernizing generation technology to where it suits a modern society and a modern grid. But I think the missing piece here, especially for a global view, is power delivery. We're not going to go and, as we just talked about, there's a lot of utilities who are no longer serving areas that they used to serve because it's just too hard, too expensive. Every mile of distribution or, God forbid, transmission power is an incredible investment that I think, as we look forward, going to be the same as landlines. No one builds landline telephone lines anymore. We all have cell phones. We don't need to be sinking billions and billions of investment into brand new transmission grids. We need to reimagine how power is delivered and to think of having an array of Emrgy systems all feeding into that battery charging station that subscribers or community members can come in, unlock their box, pull their battery, and use it for mobility, for residential, for entrepreneurship and starting businesses, for health and human services. It's just, to me, what could be more important than solving that piece? So I love what you told me about this company in Bangladesh. I love that vision, and having a baseload resource to keep charging those batteries all the time could be the most impactful way to use this system in mass.
Absolutely. We discussed that last time also. Today's energy systems are strange. You will find that, say in Australia, for example, all the people live on the east side, all the energies are on the west. If you go to any country, somehow, always people living here, energy sources somewhere else, and you need all these transmission lines. We once, over a drink, few of our friends were going through country by country. Why is that? But then again, you flip the coin. People always lived close to rivers. That's how civilization grew, right? So if you bring hydropower, especially micro, suddenly transmission lines and others maybe minimized or even not needed, no? Because mindset was, again, river coming, dam it up, and then you create a reservoir, then it's a big problem because you diverting resources, navigational issues, rides upstream, downstream. Yeah. And then you just said, I won't touch anything. All I want is little hydropower that will take excess energy from the stream or will take very little, and you put it where you need it. You suddenly solve lot of problems and really hit it hard, the mindset, shattering that mindset.
We like to think so. And I think we have really spent so much time refining this vision, refining the product, getting everything ready. Like, we got to go put some of these in. That's what we have to do next. Have a fleet in the US. Like I mentioned, we're already feeding power to PG&E and Rocky Mountain Power and some of the biggest utilities in the United States successfully. But it's now time to spread the wings a bit. And really, we've been hesitant in doing so just because I actually, in my university studies, I did a lot of research around international development and success factors toward successful infrastructure projects. Unbeknownst to me that 10 years later, I would start an energy infrastructure company. But so much of the success of any project, whether you're in energy or transportation or anything else, is the effective collaboration with the local community that's going to be owning, using, and getting life out of that system. And maybe I've been a little bit scared and scarred from that. What I don't want to do is prematurely go out and put equipment everywhere and then not be able to really properly service or maintain or instruct or enable the life that this really does promise. When you think about it, a no-brainer. We've been building our cities and towns since the beginning of civilization, using that water for transport and for drinking and for bathing and for crop production and everything. We should be using it for our energy as well. And if we can do that in a way that preserves the integrity of that waterway, it's a no-brainer. Of course we should be doing it. We just want to make sure we're doing it the right way. And now is the time. I think we're ready. I think that this is an era where we have seen the incredible benefits of distributed power. Like you said, having a solar panel and battery can be hooked up quickly. We get a taste of what it should be. And now coming in and bringing in a complement to that solar that really builds it up and brings that base load, nature's battery on the bottom of it to form that foundation is critical. Yes, I agree.
I think your slogan should be not zero marginal cost solar. It's a zero marginal cost 24/7 electricity, no? Because, I mean, I recently bought an electric car in Manila, and I live in an apartment, so one concern is, what do I charge? But then I realized there are a lot of free charging stations still. And then when you realize that you can charge for free, you really don't worry about costs. And just imagine if you could give that freedom to the global poor, lack of a better word, how much opportunities it's open up, because you might have a diesel gen set. Still, you have to think that you have to buy oil. That oil comes somewhere far from Middle East, right? And it's expensive. So people are very careful as to how much to use, when to use, optimum use, and it gets stolen and other. But if you just turn it into a sort of fixed cost, already paid, now whatever we get out for free with electric vehicle, drone technologies, all these DC motor appliances.
As you're describing the usage of the diesel, that scarcity that they experience, the scarcity of have to buy this fuel, when we're going to have the money to buy this fuel, how frequently I can buy it, that scarcity mindset around energy is something that many communities experience every single day. And it really limits many of the things that they're doing that have nothing to do with diesel, just living under that mindset. And when we can effectively unlock the abundance of energy that there really is on this planet, there's an abundance of water that's flowing all over this world, 2 million miles worth, according to the UN's latest estimate. Being able to unlock that abundance for people, I think it's going to spark new ideas, new businesses, new education, I hope. I think that it will be a game changer.
Yeah, I'm just imagining a couple that I brought from Kyrgyz Republic to ADB on one of the Asia Clean Energy Forum, just to hear their story. These are honey farmer. They're on the street somewhere along to a hydropower. So I once stopped by and said, what do you do? They make honey, pure honey. And Kyrgyz honey is one of the really best honeys that I have tried. And I was talking to her, so what do you do with electricity? They said, we have a little pico hydro, but it dies most of the time. We throw in the river, cabling it, and have a little solar, doesn't work. So I was saying, if you have a continuous 300 watt, what can you do? And this gentleman was explaining, I'll do this, I'll do that, I'll do that. So we put a 300 or a 600 watt solar panel with a battery. And I went back after a year. Now they have a little jam factory. They're like one of the largest producer of honey among all the street honey vendors there. It's changed everything. They have a fridge. They're preserving. They gave me a jam that we make marmalade with this. They're looking at YouTube, downloading recipes. It's unbelievable. This 60 plus couple, and I have the video when I brought them to Philippines. They have never been on a plane, so I brought them to share their stories. And you can change with your technology million of those lives in the next 5 years easily.
It would be an honor and a dream to be even a tiny part of that. But I do want to just mention, 'cause I think I've shared the grand vision and how incredibly amazing this can be. I do want to counterbalance it just for a moment and click on something that you said there, which was that their pico hydro kept breaking down and not working. And one thing that we haven't really talked about it is that water is a powerful force. It's a force to be harvested, a force to be used, but it's also a destructive force. When there are floods, when there are levees that break or dams that break or things like that, or even just in the general course of canals or rivers that run, you have very large logs, you have different construction, animal, wildlife constructions, things like that can be really destructive. And so I do want to just mention that's one of the reasons why we spent a lot of time on gathering field data, making refinements, making sure this is robust, because water's very destructive. And it's certainly quite a bit more complicated than, for example, putting a solar panel up that certainly needs to be cleaned. But I have some here at my house, and if I forget to clean them, it's going to be okay for a bit. Whereas with hydro, if you have a bearing that fails or a gearbox that fails or something and you don't address it, the whole system, it can ripple through the whole system with maintenance issues and mechanical issues and things like that. And for all of the benefit it can provide, it has to be right. Everything has to be installed correctly and level. It has to be placed in an area that can hopefully mitigate some of the more destructive elements, whether that's destructive water chemistries, caustic waters, things like that, whether it's the type of wildlife or debris that can be in a channel. And so I think that all of these things are overcomable for sure. Very low tech, simple things. And the way we've done a lot of our part selections and maintenance cycles and things like that are with exactly this in mind, that we're not going to be able to attend to the system every day. And if and when something breaks, that other parts of the system are shielded from ripple catastrophic failures and things like that. That is one reason that we've been so focused on it. But I think at this point, we have lots of operating hours on the system, thousands of operating hours on the system. Here in the US, we have made refinements in some of our selections on the mechanical components. And I think we're in a good spot now to start that expansion, but it shouldn't be taken lightly, because I think it's over 90% of all climate disasters are water related. Water can be incredibly negatively impacting in many ways. And so we just have to be very careful that we can put something in it that can both harness the power of it as well as withstand the destruction of it.
Now, what's your plan to bring that story to the global market, or not even climate, just the energy scene? Because we met in Paris in an international hydro association. I can't believe it's almost 6 years. So are you planning to take this to one of those COP events or some global events?
I would like to, yes. I have considered COP in the past. And fortunately, I've had a couple of children in the past few years too. And while I do a lot of travel around the US, and I'm supported by a 20-person team here in the US, so I'm not a one-woman show or anything, but when you're presenting your vision on the international stage, it needs to be me. I hate to be that founder, but it just is what it is. And it's been pretty challenging for me to travel internationally the last couple of years. That said, I am not planning to have more children, and my children are now My daughter is now 18 months old. And so I am free from many of the sort of new motherhood constrictions, which is just part of life. I have a passion in Emrgy and the climate and renewable energy, and I have a passion in motherhood and raising my children. And so I'm always balancing those two. But now that my daughter's 18 months, I think looking out at a horizon of the next 6 to 12 months, identifying some key avenues and channels where I can elevate this story and develop the partnerships that are needed. This podcast being one of those, we'd love to find some dedicated partnerships for the right regions that can really make sure that not only do we have the technical expertise and the commercial expertise in building out a local business, we bring in the local regulatory and sort of policy side, making sure that there are frameworks for installing these. As many people probably know, there's a lot of regulatory considerations anytime you're installing hydro. And then ultimately that community piece that I mentioned earlier is so important. We are looking for partners that can really address all of those areas locally, and we can be both a technology supplier as well as a partner in advising on ongoing maintenance. We didn't even talk about remote monitoring, but I can see the health and performance of every turbine across the globe at any time from my iPhone, and making sure that we're a close partner with everyone who's operating these systems is a key part of how Emrgy as a company will mature. But I think local partnerships are going to be key. So if folks in the audience are listening and have ideas on that, I'm all ears.
Yes, but along the same line, if there were 20 other Emilys out there said, how can I be Emily Morris? How can people access you? And what do you tell them? What should they do? There may be a lot of young entrepreneurs like yourself, especially women, say, if Emily can do that, managing with 2 children, I want to be that Emily and I want to change the world as well. How do they access you and what should they do? What are
Yeah, this is a very deep passion of mine. It is to explore and to hopefully, I talked a bit about mastery earlier. I'm always in pursuit of mastery. I hope to master having a successful business and also having enriching family life. But it's hard every single day. And one of the things that I have really learned, especially over the last year, is a lot of decision making that used to be very value driven. Would I rather go to this event or would I rather travel here? A lot of the decision making is more sacrificial driven. Is it more impactful if I miss my child's soccer game or if I miss this big meeting? Which one is more of a sacrifice? Which is something that I hope to graduate out of soon. But it is something that requires a lot of logistics planning. And I've said many times, you have to absolutely love and be ruthless about what you're doing, or else it's not worth it. If you're half in, family's going to win every time. And I definitely would love to talk to anyone about this more. Would love to learn from you and how you've been able to manage it, hopefully with as minimal sacrifice driven decision making as possible. And just, I guess, trust that you can do it. Anyone can.
Yeah, it is hard, but yes, how the families will judge later on when they grow up, it's a very different story as to what they say now. But longer term, what it matters, I think that's very important. And I love that emotion, love the passion that you bring into this. I think that's what keeps us alive. That's what I think will solve eventually climate change, because the technology that we need to solve climate change is here. It's just people like you working on those, bring that solution. Is there anything else I could have asked you, Emily?
I don't think so. I think this was a great chat. I always love spending time with you, and so many of the inspiring stories you said today. I would love to learn more about the farm in Kyrgyz Republic. That sounds incredible. And the company in Bangladesh that is pioneering how power should be delivered, and anywhere I can connect in and weave a teeny bit of hydro in part of that story, I would love to. I appreciate spending the time with you, and I appreciate the platform to use this voice and share this vision. And hopefully we'll check in again soon.
Thank you so much. Thank you.
Thank you.
We hope you enjoyed this episode of Energypreneurs.
If you enjoy this, don't forget the full video is on YouTube. Just search Energypreneurs.
Thank you. See you next time.